Okay, next lesson is solving for the surface area of a pyramid. We just solved for the surface area of a prism. And remember, area is solving for how many squares make up that side, and then you add all the sides together to get the surface area of that entire solid. Well, the solid we're dealing with today, again, is a pyramid. It's a little tricky, and you're going to be introduced to a new symbol today to represent something called the lateral area, which deals with the slant height that I introduced to you before. Surface area of pyramids. We're going to start off with a simple one. So you are going to see fractions and decimals in your dimensions in your homework, but Ms. Giano is going to use all whole numbers and with something that we've seen before. This is going to be solving for the surface area of a square pyramid. Okay. Our square pyramids, remember, have a square base. And try and find it. Yep, this guy. A square base. And remember, volume is you're trying to solve for how many perfect cubes fit on the inside of this pyramid. I look back in previous lessons of why we have to divide by 3 to solve for volume. Well, that's for volume. When surface area, you're actually solving for how many squares. That's why we square our answers today. And how many squares make up that net of surface area. So like I like seeing my graph paper right now. How many perfect squares do I need in order to wrap this if it were a present, for example, all the way around? Let's go ahead and start with drawing it. If we were to draw a square pyramid, you draw your square first, put your point at the top to show your vertex. All lines go to corners to create the edges. Now, when we have drawn pyramids in the past, I showed you the true height. So like the Great Egyptian pyramids, if you were to enter and go into the center and look straight up from the center, that's a true height. Today, we are dealing with the lateral height. So this, again, if you were to walk into like a Great Egyptian pyramids, which are square pyramids, and walk to the center of it and look straight up, that's the true height of the pyramid. Well, today, we're dealing with the slant height of the pyramid. So this is where they are two totally different dimensions, by the way. This is the one we're using today, the slant height, also known as the lateral. And that would form a 90-degree angle down there. And that slant height, I'm going to say, is 8 centimeters. When I'm going to say this is, I didn't draw it this way, but it's a 5 centimeter by 5 centimeter square base. Okay, I'm not using my graph paper for what it should be, but this is what we're going to use. Let's write a vocab word again of what lateral area is. And lateral area is technically, I'm going to put it in quotes, the face area of a pyramid used with slant height. Okay, so when you do 1/2 times base times height to solve for the area of this side, or this face, I should be saying, the slant height is what you're using for that H now. Not the true height inside that pyramid, okay, the slant height of the pyramid. So let's go ahead and solve for the area of just the base first. We know we have to use length times width because it's of a square. So that's 5 times 5, which is 25. Let's set that aside, 25. We're going to have to add it to all the faces later. Let's go ahead and solve for the face area side, which is, again, your lateral area. This is a face. Okay, it's a triangle. It's a face, 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 face. There's 4 faces on a square pyramid because, okay, all of those because a square pyramid has 4 sides. So once we solve for the area of one face, we're going to multiply it by 4 or add it 4 times to get the total along with that base. Centimeters squared, by the way. We're going back to squaring our answers because we're solving for area. Okay, we got to use 1/2 times base times height because that side is a triangle. So using that formula for a triangle, 1/2 times base times height, or base times height divided by 2, let's plug in what we have. The slant height there is 8, okay? The base is 5. The slant height is 8. 5 times 8 is 40. Half of 40 is 20 centimeters squared. So that means just one side or one face is 20. Well, because they're all equal dimensions, this one's 20, 20, 20, and 20, okay? You could do 20 times 4 for 4 sides. We should all know is 80. We're going to add that to the base area to get the total amount of surface area, which is 105 centimeters squared. So that's how many squares it takes to fill up, okay, for example, the sides, or to wrap the net of the square pyramid. Total amount of surface area, 105 centimeters squared. Okay, let's do another one. And this example is going to be of a triangular pyramid. Solving the surface area of a triangular pyramid, let's go ahead and just draw one first. Okay, not true height, we need the slant height. So I'm going to choose the back of it to recognize the slant height, the back side of that triangular pyramid. So this is this guy, and I kind of drew it like this. I'm going to find this side, which will give me all 3 sides. The height is going to be, the slant height, I should be saying, is 10 inches, which means this slant height is 10 inches, 10 inches, 10 inches. Okay, slant height is 10 inches, different from the true height. Slant height is 10 inches, and it's going to be a perfect 5 inch by 5 inch. Okay, it's a isosceles triangle, 2 sides same length, 5 inch by 5 inch base triangle. Let's solve for the base of the triangle first. Area, 1/2 times base times height, so 1/2 times 5 times 5. Again, the base, 5 times 5 divided by 2. 5 times 5 is 25. Half of 25 is 12.5. So 12.5 inches squared. We just solved for the area. I'm going to do some shading this time for just the base. Let's solve for the surface, or the lateral area now, for just one of the faces. We're still using 1/2 times base times height. Okay, because it's still a triangle. The base was a triangle, so we had to use 1/2 times base times height. The face is also a triangle, so we got to use 1/2 times base times height again. That was different up here. The base was a square, so we used length times width to find the base. The faces were triangles, so we used 1/2 times base times height. For a triangular pyramid, we're using 1/2 times base times height for both the base and the faces. Okay, let's plug in what we have. 1/2 times the base there, which again is going to be a perfect 5 by 5 equilateral triangle. So 5, and the height is 10. Okay. 1/2 times 50 is 25. Now, how many faces do we have here? 1, 2, 3. You can add 25 3 times. Or 25 times 3 is 75. So we're going to take this and this, add it together to get our total amount of surface area. And once you add them all together, you'll get 87.5 inches squared. Make sure you square your answers. And that's it in a nutshell. Just 2 simple examples for this video. You're not just always going to see a square pyramid or a triangular pyramid. You're probably also going to see like a pentagonal pyramid or something that is a different shape base. They'll usually give you the base area for that. And then all you got to do is find the lateral area and add that to the rest.